ID, the Future, a podcast about evolution and intelligent design.
Welcome to ID the Future. I'm your host, Andrew McDiarmid. Today, I'm excited to sit down with Dr. Guillermo Gonzalez to discuss his work on a revised, rewritten, and updated 20th anniversary edition of The Privileged Planet, the 2004 book he co-authored with Dr. J. Richards. Dr. Gonzalez is an astronomer and a senior fellow with Discovery Institute's Center for Science and Culture. He helped discover 2 new planets and is co-author with Jonathan Witt of the recent young adult novel, The Farm at the Center of the Universe. Guillermo, welcome back to ID the Future.
Thanks for having me.
Absolutely. Well, our topic today is a new edition of The Privileged Planet, which contains responses to critics, lots of updated facts, some new arguments, and completely rewritten and improved text. But before we get to that, I thought we could just set the stage and remind listeners how The Privileged Planet originally came to be and what you set out to do with the book. So, what was the impetus for writing this book? Did it come out of things you were researching at the time?
Yes, and in fact, I can trace it back to one particular event. It was my trip to India in 1995, which I timed to coincide with a total eclipse of the sun visible from northern India. And I observed it, and after I returned, I thought about it, and I realized, wow, that's quite an exceptional thing, these total eclipses that we can view from the Earth. And so I started thinking about it I started putting together a research paper, which was eventually published in 1999 in the Journal of Astronomy and Geophysics. The title was Wonderful Eclipses. And I made the connection for the first time between our ability to observe eclipses and the habitability of the Earth. The fact that the best place in the solar system to view solar eclipses happens to be also the most habitable place, and that is not just a coincidence. And so that was the start of this inquiry that became the Privileged Planet thesis. And by 1999, 2000, I had accumulated several examples with the solar eclipses one being the first, which is why it's the first chapter in the book. And I gave a talk on this, a very early version of the Privileged Planet, at Yale in 2000. And so that forced me to kind of consolidate my ideas and produce a cohesive argument, which at that time was still incomplete, again, only about half as many examples as eventually ended up in the book. And then I submitted a proposal to a competitive grant by the Templeton Foundation, and I think that was announced in 2001, if I recall. So I did win that grant, so I used that money to write The Privileged Planet while I was a postdoc at the University of Washington. And then I finished that project while I was in a tenure track position at Iowa State in late 2003. And so during that time, from the very beginning of writing the book, Jay helped me. He was a collaborator with me on the book. But yeah, I don't think many people realize that I actually did official and intelligent design research with the blessings of 2 major research universities who administered that grant money to pay part of my salary while I was writing the book. University of Washington and Iowa State University.
Yeah. And did you feel like you were onto something that other people weren't? I mean, were there other people exploring this issue, or was it relatively new?
It was new, although when I gave that talk at Yale in 2000, another person that I had just begun to get to know, Robin Collins, a philosopher at Messiah College, gave a similar talk, but from a very different perspective, from a theoretical perspective, how the laws of physics appear to be set up to be discoverable. And so his thesis was similar, had some similarities to mine, and so I found that very refreshing, but him coming from a very different direction. And so we kind of both marveled after we both gave our different presentations at the conference at just how much overlap there was in our basic conclusions that the universe appears to be set up to be able to discover the truths of nature. But apart from that, really, it's a brand new argument. People had been talking about the fine tuning of the laws of physics and cosmology in order for the universe to contain life, but nobody had really been talking about how the universe is fine-tuned or apparently set up so that we can discover the universe around us to optimize science.
Right. You were seeing the pattern there that not many others were seeing, or really nobody at that time. Well, the main point of the original book is that the conditions allowing for intelligent life on Earth also make our planet strangely well suited for viewing and analyzing the universe, that is, for scientific discovery. And in the book, you and Jay proposed that the bold hypothesis of this suitability is more akin to a cosmic conspiracy than a coincidence. Was this a bit of a eureka moment for you, or did it develop as you were writing the book, as you were assembling these ideas?
So as I mentioned, I had already come up with several examples of this correlation between the needs of life and the requirements for doing science before I started writing the book. And then as I was writing the book with Jay, I came up with a few other examples because I was forced to sit down and then just concentrate on this topic for basically 3 years. It was not the only thing I did. I was also still doing research in astronomy and publishing papers. In fact, there was a kind of overlap there. My research on the properties of stars and astrobiology certainly helped me think through these issues as I was writing the book and come up with these new connections. And so I'd say about half the ideas or half the examples were before I started writing the book, another half while I was writing the book. We have what's called a cumulative case argument. So you build it up one example or one case at a time. And the more examples you can find of this correlation between life and scientific discovery, the stronger the argument becomes. And so we wanted to see, how many examples of this we could find.
Well, The Privileged Planet pushes back on a very different opinion that our earthly existence is not only rather ordinary, but in fact insignificant and purposeless. Carl Sagan used to typify this view, when he talked about the pale blue dot and how insignificant our lonely planet was in the great enveloping cosmic dark. Tell us a little bit about this idea behind that, the Copernican principle, they call it, or the principle of mediocrity.
So this is an idea that we had to confront because our argument says basically the opposite. We're, in fact, the title of the book, The Privileged Planet, that we are privileged. We're not totally mediocre or unimportant. This idea called the Copernican principle says that Copernicus, in proposing in 1543 that the Earth is not the center of the cosmos, that the Earth instead revolves around the sun, was a demotion. That's the argument, that the Earth was and its inhabitants were dethroned by this moving us away from the center, because the center was a place of great privilege and metaphysical significance. That's basically the Copernican principle. Of course, Copernicus didn't say anything of the sort, and in fact, he thought he was promoting its status. But so we explode the historical aspect of this myth, first of all, by noting that the Greeks really are the ones who put the Earth at the center for philosophical and just commonsensical views. It seems like we're immobile at the center. They had this idea of the four basic elements: earth, air, fire, and water. Earth was the heaviest, so it naturally sank towards the center. So it's not so much that they put the Earth at the center because they wanted it to be there as the most important place, but rather it was actually the place where the heavy things just naturally sank to. So it was the sump of the universe. It was the bottom of the universe. It's where change and decay occurred. And so actually it's the heavenly realm was perfect and unchanging. But we also tackle the logical fallacy that really you shouldn't try to equate geographic location, specifically a geographic centrality, with metaphysical importance or metaphysical significance. If we were at the center of something, it doesn't mean we're the most important thing just because we're geographically at the center. But we have shown in the book, I think, that we are privileged in our location in important ways, such as our ability to measure and discover the universe around us. We do have privilege a privileged place in the universe. It's not central in the sense that it's not the geographic center of anything, but that really doesn't mean anything. So yeah, this is an involved discussion because it involves a historical myth, a logical fallacy, and so you have to tackle all those things. And then, of course, knowing the science, where are we in the universe? What is our status of our location? And we argue that it gives us privileged views.
Yeah. Well, the bold argument of the privileged planet certainly made it controversial when it was released, and you paid a heavy price personally for your work on it. Can you tell us a little bit about that experience?
Yes, of course, we published the book in 2004, spring of 2004. It was kind of semi-quiet for a while, although I had some pushback from a couple of atheist professors at Iowa State, where I was an assistant professor at the time. And but really, this controversy really took an elevated level when a premiere of the documentary based on the book was shown at the Smithsonian in Washington, D.C. I want to say late May or June 2005. And that was really created a firestorm of controversy. And one of the professors who had been criticizing me on campus after the book was published, an atheist religious studies professor by the name of Hector Avalos, took me on as his project. And he started circulating a petition or a letter that was signed by something like 120 professors on campus denouncing intelligent design. And he knew I was very vulnerable, that I didn't have tenure yet. I hadn't had my tenure review yet. And so obviously he wanted to create this controversy to get rid of me. And frankly, he succeeded. So I was denied tenure, even though I had a stellar, pardon the pun, publication record in my field of astronomy. And I was able to land another position after that at another college. But then, unfortunately, the controversy followed me to another position I had more recently at Ball State University, another tenure track position. And I was also denied tenure there, also because of my connection to intelligent design. So I've lost tenure twice because of my public writing on intelligent design, in particular the book, The Privileged Planet, even though it was officially approved by 2 research universities. It doesn't matter. There was a Freedom of Information request from Iowa State, and it was revealed that the professors are conspiring behind my back in my department to get rid of me because they didn't want to be known as the intelligent design or intelligent design friendly department.
Yeah. Yeah, it's such a shame, and I'm so sorry that happened. And yet you got the word out, you put these ideas out, and the world is the better for it. But it's so amazing to what lengths they go. These sorts of people. What are they afraid of? Why can't they let these ideas be aired and debate them civilly? I mean, that really betrays their perspective and just what they're standing on, which isn't much if they're so afraid. Fast forward to this year, 2024 brings a brand new, updated and revised edition of the book. Something that you guys, Jay was telling me, had planned from the very beginning. You knew that there would be a solar eclipse this year, and it would be a great time to put out a 20th anniversary edition.
That's right. In fact, we took advantage of that eclipse opportunity. We both were in Waxahachie, Texas, to observe this beautiful total eclipse of the sun. That was my third. First one was in India, 95, and then the second one was the Great American Eclipse of 2017, and then this one in 2024. And it provided an opportunity for us to talk about the Privileged Planet also in some venues. So we were able to finish revising the book in time to release it this year. We were hoping to get it done so it could be released in time for the solar eclipse in April, but that didn't happen, unfortunately. So, but it's okay. It's being released this week. We're talking right now on August 28th, the day after it was officially released. The new edition brings some, of course, completely rewritten text, so it's more readable, more accessible. We explain some of the more technical subjects more carefully, so it's accessible to a wider audience. there was a number of studies that I've done in the last 20 years that are relevant to the privileged planet, and I wanted to incorporate those into the book. So, for example, one of them was a paper I wrote in 2009 on what are called mutual eclipses. Mutual eclipses are eclipses between pairs of moons around a given planet. And so one moon casting its shadow on another moon, for example. And that's something I had wanted to discuss in the original edition, but I just didn't have time. I wrote a paper about it, doing the statistics of mutual eclipses in the solar system, and they do not compare to our eclipses. They're very short duration, typically seconds or fractions of a second, unlike our eclipses, which can last up to 7.5 minutes. So that was nice to be able to incorporate. And there's many new research papers that we cite now that have been published since 2004. So we've updated the science throughout the entire book. Whenever any scientific study was published that was relevant to the privileged planet, I updated the older references. So you'll see lots of citations in the notes to the literature between 2004 and 2024. So we want to keep up to date. And, one of the areas with the biggest changes has been the study of exoplanets. So back in 2004, there are only around 100 known, and now there are nearly 6,000. So the statistics are much better now than they were back then. And so we've updated some diagrams in the discussion of the exoplanets and how many are like Earth or not like the Earth. And as it turns out, it's more strongly demonstrated now than it was then just how anomalous the solar system is, how atypical it is with its nearly circular orbits for the planets compared to exoplanetary systems, for example.
Yeah. And some critics claim that every discovery of an exoplanet somehow weakens the argument that you put forth, but that isn't true, is it?
Right, because we have discovered lots of planets, but they're also surveying a lot of stars to find them. But we're finding that they're not quite like the solar system and their properties. And many of the ways that they're different are ways that would make them life unfriendly. So, we don't argue that the Earth is unique in the universe, although our argument is based on the assumption that Earth-like planets are rare, and that's certainly been confirmed. Earth-like planets are very rare. And so that plank of our argument has only been strengthened by the new findings.
Well, another argument you made in the original edition has gotten more support over the last few decades, and that is that the Earth and our solar system happens to be an excellent platform for space travel. What did you mean by that, and how did you come to that conclusion?
Right. So that was another paper, based on another paper I wrote. This one, I believe, was published in 2019 or 2020, where I argued a couple of other people had basically published papers saying how much better the Earth is compared to, say, super Earths, which are terrestrial planets more massive than the Earth, and how much harder it would be to launch rockets from them because of their higher surface gravities. And so I was motivated by these two scientists to write my own paper on that and expand on that idea and investigate it more deeply. And of course, yes, the higher the surface gravity of a planet, the harder it is to launch rockets from. And you have very smaller and smaller payload that you can send out beyond the planet, the more massive the planet is. The fact that we have dry land, the fact that we have an oxygen-rich atmosphere, oxygen being the best oxidant for rocket propellants. It's a curious thing that water, which is so common and seemingly so innocuous, is actually one of the most powerful rocket fuels. If you split it apart into hydrogen and oxygen, then you combine them together again, right? You have liquid hydrogen and liquid oxygen in rocket tanks as a common type of rocket fuel.
Yeah.
And we have it in abundance. But the placement of the Earth in the solar system also aids in interplanetary space exploration, and launching even interstellar missions is easier from the Earth than it would be around a planet in the habitable zone of a less massive star. There are multiple ways that the Earth and the solar system seem to be optimized for space exploration. Of course, we have all the material resources on the Earth to allow us to to build rockets, metals that are easily mined on the surface of the Earth. We have fuels, fossil fuels. Many people probably don't realize that the first stage of the Saturn V was not liquid hydrogen or oxygen. It was kerosene. So it was a fossil fuel. So fossil fuels have helped us also in the space exploration.
Well, I understand you also filled out the discussion and the critique over directed panspermia as a valid hypothesis. Can you tell us a little bit about that?
So that's an appendix to the book. So we have the same two appendices. And this one, the one on panspermia, was we did a complete rewrite. I had written a chapter a few years ago in a book where it was about panspermia. And I discussed how likely it would be based on a survey of the literature, on the most recent studies on it. And it's very unlikely. Now, directed panspermia is a special class of panspermia. Just to remind everybody, panspermia just means transfer of life in space between planets or between planetary systems. Now, directed panspermia is where you actually have an extraterrestrial civilization purposely taking life and seeding other planetary systems. So, we have to have evidence of other civilizations before we could take that one seriously. But some people have cited directed panspermia as a solution to the origin of life problem because it seems so insurmountable. They actually went to the extreme of proposing directed panspermia. But it's just there are multiple stages in getting life from one planet to another, especially between planetary systems. You have to launch it from the planet. You have to survive the long trek through space with radiation environment. It has to arrive at a planetary system, be captured, and again, it's a long process too, and then survive impact, re-entry on that other planetary system. And on Earth, life is not just isolated. It's kind of it's ecosystems, and living things depend on each other for various things. So it also, just from that perspective, it's very unlikely to have a single species of a single-celled organism just populate an entire other planet without bringing the whole ecosystem with it. So for many reasons, it is extraordinarily unlikely based on the latest research.
Yeah, and I'm glad the new edition builds on that critique. Well, what about general relativity? I mean, that's a cornerstone of modern science. And in the new edition, you and Jay mentioned that the theory of general relativity has received new confirmations in the last decade. Why do these discoveries matter?
So the big new finding with general relativity since The Privileged Planet was published in 2004 was a discovery of gravity waves for the first time directly in 2015. Interestingly, almost exactly a century after Einstein first proposed that. And so gravity waves are produced by, for example, masses like neutron stars or black holes that are very massive, that orbit very close together. And they create disturbances in the space around them that travel out like waves in a pond when you throw a pebble in a pond. And so using very sensitive interferometers underground, physicists discovered the gravity waves for the first time. Most of these, I believe, are produced by inspiraling black holes, although some could be neutron stars also inspiraling, but most of them are supermassive black holes detected at great distances. So it's a completely new kind of direct confirmation of general relativity. They had been inferred indirectly prior to this through timing of binary pulsars. In particular, that they're gradually orbiting faster and faster, some of these binary pulsars, because they're losing energy by emitting gravity waves. But see, that's kind of an indirect inference to them. This measurement in 2015 was a direct measurement. And so why is it important? Because general relativity is the foundational theory for modern cosmology, for describing how the universe changes dynamically, how it expands, and leads us to conclude that the universe had a beginning. So it's the most important foundational theory in all of cosmology, and I'd even say in all of physics.
And it must be rewarding for you to see the arguments that you formulated being continually confirmed in various ways with new discoveries and, revisiting old discoveries.
Yeah, absolutely. Yeah, it's fruitful. It leads one to make certain predictions and also to have certain lines of research that bear fruit.
Yeah. Well, not only are we extremely well placed to observe the universe where we are, it sounds like we're also well timed. In chapter 9, where you cover cosmology, you conclude that we live in what you both dubbed the cosmic habitable age, and that we're living during the best time to study cosmology. Tell us about that. That's intriguing.
So there is I like to call it the cosmic habitable age, because age or time is probably the most important parameter when you're discussing the whole universe as a whole and Hall's bulk properties. They do change over time as the universe expands. The galaxies are moving farther and farther away from each other. Also, we find, for example, that the star formation rate is declining over time. So the raw material for stars that's accreted by, for example, the galaxy, Milky Way galaxy, is declining. And so in the future, the rate of star formation will be less. The stars like ours, relatively massive, relatively short lifetime stars like ours, will be very rare. And so there is this period of time in the history of the universe when we can have life-friendly sun-like stars like ours exist. And the galaxies that we can see are still relatively bright, and they're still relatively nearby. So in the future, as the galaxies continue to move away from each other, they will be dimmer and dimmer and dimmer. Eventually, we won't see any galaxies around us because they'll be too far away and moving too fast away from us. In fact, there'll be something eventually called the event horizon that will limit how much we can see in the universe, because the things that are far enough away will be moving away from us, apparently the speed of light. And so their light will never reach us. So Lawrence Krauss, no less, a famous atheist cosmologist, stated shortly after the cosmological constant was discovered, which is the evidence that the universe is not only expanding, but it's accelerating in its expansion. He commented about 20 years ago that we are living in a special time to do cosmology, because we can observe the maximum number of galaxies relatively nearby and study star formation, all those things. But because of the cosmological constant, not only are the galaxies moving away from us, but they're accelerating in their recession away from us. And so the distant future is going to be a very boring place to be a cosmologist. There will be very little you could see. And not only that, the microwave background radiation is fading as the universe continues to expand. And at some point in the future, we wouldn't be able to detect it anymore. And that was the linchpin evidence that the universe started in a hot, dense state with a Big Bang that had a beginning. And so cosmologists in the future wouldn't even have that evidence available to them. They would mistakenly believe they lived in an eternal universe, probably, not having the evidence for a beginning.
Yeah.
And so that's, I think, quite a remarkable thing, that we're living at this very special time to do cosmology.
Yeah, it truly is. Privileged in space and time. That's phenomenal. And it means that it's the perfect time to bring out a new edition of The Privileged Planet.
Yeah.
You don't know how long you've got to do that.
Right.
Well, the closing chapter of the book fields 15 of the best objections that you and Jay could muster that could be put forward against the book, against the arguments of the book. And I just wanted to spend our last minute or two just discussing a few of those. What would you say to someone that says, it's impossible to falsify your argument? What would need to be discovered to falsify your argument in whole or even in part?
Yeah, so arguments based on certain assumptions, and it's, as I mentioned before, it's a cumulative case argument also. Easiest way, for example, is to show that the examples we came up as our cases supporting the privileged planet thesis are in fact mistaken, and maybe the science is not right, and the correlation is only apparent. It really wasn't there because we were mistaken about the science concerning those examples. That's always possible. I mean, like any scientific theory, ours is empirical. It's based on empirical evidence. And it's open to either being strengthened or falsified. We have many examples, so you'd have to show that more than just one or two are wrong, basically, to falsify the argument in that way. And one of our most significant assumptions is that life anywhere is going to be based on carbon in a liquid water medium. And so that's how we can extrapolate from the Earth to other places from what we know about life on Earth. Then we can posit, well, we look for water in other places. Those places that don't have water are not going to be habitable, and so on. They don't have enough carbon or other life essential elements aren't going to be habitable. So if you prove that life can be based on something else, like silicon or some other medium other than liquid water, then that'll put a big dent in the argument. But the evidence is just building that you can't get around carbon and liquid water as a starting points for life.
Yeah.
So that's what I would say there.
And you do note, as you respond to that objection in the book, that another way would be to find a distant, very different environment that, while quite hostile to life, is nevertheless a superior platform for making, diverse scientific discoveries. So that'd be another way to falsify, wouldn't it?
Yes.
So that argument doesn't really hold too much water, because you can indeed falsify these things. Well, what about this objection? There are phenomena we cannot observe or measure. Your argument's biased toward what can be discovered.
That's true. And in that way, it's like any other scientific theory. It's based on what we actually measure in the universe and observe. Now, having said that, a large aspect of our argument is also theoretical. Just a little while ago, we were speaking about the future history of the universe. We can't observe that. We can't observe the future yet, but we can predict what it's most likely to be like based on our best current models in cosmology. And so we use theory, the cosmological models, to extrapolate into the future. For example, knowing what the value of the cosmological constant is, how far apart the galaxies will be, let's say, in 100 billion years, and how hard it would be to make observations of those galaxies. And so there are various aspects of our universe that we can't see directly. We can't see the very early universe when it was very hot and dense, but we have some clues that we can observe combined with physical models to infer what it was like at that time. So that's what I would say. We combine what we can see, observations, with theory using our best current models in physics and cosmology.
Well, we've just explored two objections, but you do address 15 in that last chapter of the book. So I recommend that to listeners as a great place to turn when you're debating these topics. Well, Guillermo, that's all the time we have for today to explore this, but I really want to thank you for your work putting together this new edition. And this has been an amazing journey for you for over 20 years. And it's so good to see it still going strong and being held up by even new discoveries. So I wish you well as you put this new edition out.
Thanks so much.
Well, to get your copy of the revised, rewritten, and updated 20th anniversary edition of The Privileged Planet, go to privilegedplanet.com. That's the website, privilegedplanet.com. Don't miss this new opportunity to dive into the latest scientific evidence showing that Earth is designed both for life and for scientific discovery. Again, privilegedplanet.com. Well, for ID the Future, I'm Andrew McDiarmid. Thanks for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.